In this lesson, we're going to look at the equation of a straight line. Okay, so the first thing we need to know about is the gradient of a line, and the gradient of a line is defined to be the change in y divided by the change in x at any point on a line. So the change in y in this diagram is there. Okay, this length here is the change in y, often referred to as the rise, and the change in x, what's between any 2 points, is this distance here, often referred to as the step. So we need to be able to calculate the gradient of any line. So if we look at this particular line, we have a change in y, or a rise, of 4 and a change in x of 8. So in this particular case, the gradient is 4 divided by 8, which is a half. Now that is really important. It's part of our equation of a straight line, and we'll need to look at that further when creating this overall equation. The second thing we need to know about is this position, where we cross the y-axis. Now in this particular example, we cross the y-axis at the point where y equals 3. This is known as the y-intercept. So we have a y-intercept of 3 in this case. Now every single straight line equation can be written as y equals mx plus c. And m is the gradient and c is the y-intercept. So this particular equation for this particular line is y equals a half, because the gradient was a half, x plus 3, because the y-intercept is 3. Let's have a look at this one and see if you can understand that pattern again. Because here we've got the line y equals 2x plus 1. And you should notice that it crosses the y-axis at 1. And that is where this 1 here is coming from. If we look at the gradient, what is the change in y divided by the change in x, or the rise over the step at any 2 points? Let's have a little look and see if we can work it out. So let's pick this particular point here at 2, 5, and any other point on the line. Let's pick this particular point here at -1, -1. Now, if we look at the change in y divided by the change in x, we should end up with 2. So the change in y is 6, the change in x is 3, and if we do the change in y divided by the change in x, we get 2. And that is where this number here, that 2, is coming from. And that's why the equation is y equals 2x plus 1. Now, on the picture in front of you, we've got 4 different lines, and the equation for each one is given. So first of all, let's just check our answers again. The top left equation has a y-intercept of 4. There it is, crossing at 4. As we've seen, y equals 2x plus 1 has a y-intercept there of 1, and it crosses at 1. Y equals x minus 2 crosses at -2, and y equals 0.5x minus 4 crosses there at -4, just like you'd expect. So the y-intercept is very easy to understand. Now let's look at the gradients of those lines and see if they match our gradients we've got. Now, if we pick a change in y of a change in x for each one, let's keep the change in x at 1. So in this particular example, we've got 2 divided by 1, which is 2. In the graph y equals x minus 2, if we just pick any 2 points, we've got a change in y of 1 divided by a change of x of 1, which is 1. Now, y equals x minus 2 is the same thing as y equals 1x minus 2. That's why that gradient there is 1. If we pick any 2 points on the line y equals 0.5x minus 4, let's have that point and that point. Okay, we've got a change in y of 2 and a change in x of 4. So 2 divided by 4 is 0.5, just as we've got there. Finally, if we pick 2 points on the line y equals minus 0.5x plus 4, now we've got from the top left, we've got a change in y down of minus 2 and a change in x across of positive 4. So this is where the minus comes from. It's minus 2 over 4, which is minus 0.5. Now you may be wondering, why wasn't the previous example negative? We went down minus 2 and we went back minus 4, but minus 2 divided by minus 4 is still positive 0.5. Okay, so here's some examples. Plot the line y equals 3x plus 1, first of all. Well, first of all, we know that we are going to cross the y-axis at 1, and we know the gradient is 3. Now think of it as, for every change of 1 in the x direction, that means it's a change of 3 in the y direction. So we can start marking points, and then we can join them up with a straight line. And that's my first one done. And just check, if you do the change in y divided by the change in x, you always get 3, exactly as we would expect. The second example, well, that one crosses the y-axis at 2. It has a slightly less steep gradient of just 2. So for every 1 across, we go 2 up, 1 across, 2 up, 1 across, 2 up. So although similar to the previous example, let's try a different colour for this one. We are going to have a line that looks like that. In the final question, we have got that we cross the y-axis here at 10, and the gradient is minus 2. So for every 1 across, we're going to go 2 down, 2 down, 2 down, like that. And so just joining those points up, we will get our final answer. There it is. That is the line y equals minus 2x plus 10. Now, the other way around can be done as well. If we're given the line and asked to find the equation, we can do this quite simply. We know that the answer is going to look like this. Y equals mx plus c. Now, the y-intercept in this particular case is 2, so that tells me the c. So I could jump, if you like, to y equals mx plus 2. Now I need to find the gradient, which is going to replace the m. So if I pick any 2 points, let's just have this point here and this point here. We've got a change in y. Well, it's going down 2 places, so minus 2, and a positive x of 2 as well. So minus 2 divided by 2 is equal to minus 1, and so there's our gradient. Our line is y is equal to minus 1x plus 2. We want to make sure we write in the correct notation, so our answer is y equals minus x plus 2. That's the correct answer, and that's all you need to be able to access the next piece of work. Good luck.